So I want exact trig ratios, right? So this is 1, this is -1. So how long is this? What's 1 squared plus 1 squared? 2. Then what do you do with that? Square root. So that's the root of 2. So sine is -1 over root 2. Cos is 1 over root 2. And tan is -1. Up here, choose a letter from 4. Nice bifold or trifold presentation, Crystal. Sassy. D. Tan is negative and cos is positive. Where's the only place cos is positive? Quadrant 4 and quadrant 1. But tan is also positive in quadrant 1, so this has to be quadrant 4. Yeah? Yeah. 5, choose a letter. D again, I'm getting feeling a pattern. That's X, that's Y. I need R. R is always 576, because that's the square root of 20, or square of 24, plus 100 is 676. And I think that's the square root of 676 is 26. Square root that to get 26. So, sine is -10 over 26, which of course you would simplify to -5/13. Cos, 24 over 26, which of course you would simplify to -12/13. And tan, 24, -10 over -24, which would be +10 over 24, which would be +5/13. Yeah? Without a calculator, positive or negative, should be able to do them all, yeah? Choose one. D? Cos 220, that's in quadrant 3, so it is negative, right? These will take 2 seconds. Positive, positive, negative. 7, do I need to do 7? That's Y, that's R. And sine is positive, so it has to be +5 would have to be up there or up there, right? There. That's 5, that's 13. So this has to be 12 or -12. Then when you find the angle, you know that it is 30, I think. 30 and 30, but I'm not 100% sure. Is it? Somebody did the work? Anybody? 30 and 30? Is it? Or 30 and 150, I mean. Okay. Determine exact values for the other two. That's X, that's R. So that would be in quadrant 2. That would look like this. 3, that would be -2. So that would have to be 9 minus 4. That would have to be the root of 5. So that would be, sine would be root 5 over 3, and tan would be root 5 over -2. That's how you would do those. Good? Or do people need to see that one again?
Can you do D?
Yes, I will do D. Tan is 1 in quadrant 3, yes? Which means this is -1 and this is -1, right? Because -1 and -1 would make +1.
No, D.
I'm sorry, I was doing E. What an idiot head. Sine is -1/3 in quadrant 3. -1, 3. 3 squared is 9. Minus 1 squared is 8, so that's root 8. Negative, and then you would do it. Now, of course, technically, cos is -root 8 over 3, which you would technically simplify to -2 root 2 over 3, right? But this is like, really persnickety, right? Like, I'm not usually that, right? But will future teachers and or professors and or grad students marking your work? Definitely grad students marking your work, because grad students are dicks. Damn it, that was recording. No grad student is watching this. They already know how to do it. Annie, you didn't need to do 7 and 8. Why? Because I care. Actually, you'll be able to do 7 and 8 after today's lesson. Do we want to look at 11? Do I need to look at 11? It's exactly the same as 7 and 8, or whatever we just did. 5 and 6, I don't know. 7 and 8. Are we good? Okay. That's good because it's already drawn for you. I imagine I would need to look at some of these word problems, yes? Anybody want to choose one? 17? 16 too? All right. I'll 16. Cos is 1 over 5. Positive 1 over 5. Tan is positive as well, so where must it be? First quadrant. So that must be 5, that must be 1. This must be, we don't know, right? But we do know, because what is it? How do I find the third side of a right angle triangle? C squared minus A squared. 25 minus 1 is 24. So that's root 24, isn't it? What does that simplify to? 2 root 6. And then, of course, sine is 2 root 6 over 5. Yeah? And 17, the angle between the Earth, the horizontal of the Earth's magnetic field is called the angle of dip. Some migratory bird, blah, 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 blah. The angle of dip at the magnetic equator is 0, while the angle at the north and south poles is 90. Determine the exact values of angles for the angles of dip at the magnetic equator and the north and south poles. Whoa, wait a minute. Oh, okay, well, the exact values for 90 degrees and the exact value for 0. We've already done that. It's in our notes, right? What's the sine of 90? 1. What's cos of 90? Undefined. We've already done those in our notes. It's just a bunch of gobbledygook, right? That's all a word problem is. Anything from here? I expect number 20. Is, of course, oh, that's hard to see. 20 is, of course, just this, right? And this is a 45-degree angle, yeah? So what does that automatically make this? If this one down here, okay, so everybody sees that that's what's happening here between A, right? So I'm going to draw it over here and nicer where there's not the thing in the way. If that's 45 and that's 90, what's that automatically? 45, right? So determine the measure of the angles in standard position for A, B, C, and D. Well, if that's 45, what's B? What? 135. What's C? 225. What's D? 315. Done. If the radius is 1 unit, determine the coordinates on the circle. Okay, so this is the circle, right? This radius is what? How long is this? How long does it have to be? I think you know this. What is the sine of 45? It's a gross number, yes? What's the tan of 45? Use your calculator if you need to. What's the tan of 45? 1. So that means that's 1 and that's 1, right? right? So I went out 1, I went up 1. What's that guy's coordinates? 1, 1. What's this guy's coordinates? -1, 1. What's this guy's coordinates? -1, -1. What's this guy's coordinates? 1, -1. Done. Yeah? All right. Explore the patterns. I think you're okay with the patterns.
I only understand like 21.
Okay. Well, what's the sine of 0? 0. What's the cosine of 0? 1. What's the tangent of 0? Undefined. How do you find those values? Just use your calculator. 15. You would just fill it in. And you would notice that as we go up to 60, the signs are going where? Bigger or smaller? They get bigger. So these ones are going bigger. What is happening to the cosines? Smaller. What is happening to the tans? Bigger. And then it wants you to do numbers. And what you'll see when you do numbers is the sine and the cosines. Something weird happens. Remember I showed you that curve yesterday? Sine looks like that, and cosine looks like... Oops. See, sine goes up to 90, then back down to 0 at 180. Cosine starts here and goes like that. It's at -1 when it's at 0, and it's at +1 when it's at 0. So you'll notice that there's some back and forth there. And we already know that from grade 10, right? Because at angle A, little a, little c, sine of little a is A over C, right? Sine of big A. Cos of big B is little a over C, right? Sine and cos catch up eventually, right? Same numbers. That's what we were looking for there, Brittany. This is the type of question that's actually useful, because then you start seeing the relationship between the two, not just doing a single question. And then what's obviously going to happen as I move from quadrant 1 to quadrant 2? What's going to happen to all my cos values? The cos of 45 must be the same as the cos of 135, except cos of 45 is in quadrant 1, so what is it? Positive. Cos 135 is in quadrant 2, so what is it? Negative, even though it's got the same numbers. And the extension, if you graph a line, it creates an angle, right? Determine sine, cos, and tan for theta. Well, it's 6x, right? So that's a slope of 6 over 1, right? So I went up 6 and out 1. So you would just solve it. If the terminal arm lies on this line, you would have to determine values there. So I'd have to graph that line, put it on the graph, and find the values. We all know how to graph that line. It's y equals -3/4 x. So I'd come to here. -3/4. I'd go up 3, right 4. So that is -3, 4. So I went, oh, wait, sorry. I did that backwards. idiot head. Up, drop 3, and run 4. I'd be out here. So this is 4, and this is negative 3. Then you would just do tan and cos and add them. Yeah? And the last one, consider an angle in standard position with r is 12. Describe how the measures change as theta increases from 0 to 90. Well, that's the same as this question, right? The sines are going to go from zero, because sine of 0 is 0, up to 1. The coses are going to go the other way around, from 1 down to 0. And the tans are going to go crazy. They're going to go from undefined back to undefined. Yeah? I'll take that as a yeah. Wait a minute. There's what I want. Page 203. That should be what you guys have, yeah? Now, you will notice that every question I crossed off for you had the word special triangle in it, yes? And you will notice we've done a couple of triangles that had 45 degrees in them, yes? Right? Okay, so let's talk about those. This is 90, so that makes both of these 45, yes? We all know that, right? Has to be, because triangles have to add up to what? 180, yeah? Okay. Now, if you were to get out your calculator and do some trig, because we only know the 45s, don't we? Do we know any of the sides? No, so we can't get a ratio, can we? Right? You can't tell me what tan of 45 is. Where's my little, oh, right. Tan of 45 is, we know it's opposite over adjacent, but we got no numbers there, yes? Everyone agrees? Okay. So we go to our calculator, and all we can use is our calculator, right? So if I go to my calculator and I go tan 45, I get 1, right? Okay. So what does that mean? Well, this is 45, opposite over here, and adjacent here, yes? And tan of 45... tan 45 equals 1, yes? So what's the only way to get 1 in a ratio? 1 over 1, yes? So that means this has to be 1 and this has to be 1, doesn't it? Could this be 100 and this be 100? Yeah. Could this be 7.2 and this 7.2? Everybody agrees, right? Okay. So since we know that it has to equal 1, we know that if these two are the same, it's always going to work, no matter the size of the triangle, right? So the only thing missing here is how do we do sine, cos, and tan? We've already got tan, it's 1 over 1. How do we do sine and cos? What do I need to get sine and cos? Hypotenuse. What's the hypotenuse here? What is it? The square root of a squared plus b squared, yeah? So what is it? Root 2, no matter what. So when we have a 45, 45, 90 triangle, we automatically know that the sides are always going to be the same. Yeah, I shouldn't use x because on a coordinate grid that might mess you up, yeah? So I'm going to use Z. No, Z looks like a 2. Q and Q. They're always that, aren't they? Right? Always. And what's this one? It's always going to be root what? A squared plus b squared. So it's always going to be root 2q, no matter what. Right? So if this is 7, what's this? 7. So what's this? Root 14. Yeah? Everybody cool? But it's not, it's, sorry. 2 root q. So it's because, so this is going to equal, go back to purple, 2 root 14. Why? Because this would be root 7 squared plus 7 squared, yeah? Which is root 49 and 49, 98, which is 2 root 14. Yeah, yeah? Yeah, yeah, yeah? Sorry, I'm screwing that up. Such an idiot. 7 root 2. The root 2 stays. It's always q root 2. So 7 root 2. First thing in the morning. Is everybody okay with this? This is the easy one. Is everybody good? Why is it the easy one? Because what happens if I move it? These are both in quadrant 2, yes? What happens if I move it over here? It's still 1 root 2. Yeah? Right? What if I turn it over? What do you mean turn it over, Mr. Myers? I mean this. If I make that side orange and that side purple, does it change anything? If I write the orange one down there and the purple one right there, sorry, the orange one right there and the purple one, no, I don't want to do it that way. If I put the brown line out here, which is right there, and I make that orange and that purple, is it still 1 and 1 regardless? Because the 45s are the same no matter how I twist the triangle. Everybody cool? That's a pretty easy one, right? 7, we're good? Okay, this one's different. This one's a pain, okay? So, where in this triangle would the 30 be? The top or the bottom? Bottom. Everyone agrees, yes? Which makes this the 60. Agreed? Everyone's cool? Okay. Now again, we got the same problem, right? We can't do any trig with this because we got no numbers, yeah? So what's the only thing we can do? Where should we go? Where could we go to get some numbers to put in here? We could try tan of 30, sine of 30, cos of 30, tan of 60, sine of 60, cos of 60, right? So let's go to our calculator and try them. What do you want to try first? Tan, sine, what? Tan of 30? Okay, so tan 30. Oh, barf, that's not a pretty number to work with, yeah? Okay, so let's try cos 30. Barf, that's not very pretty to work with. Sine 30. Not sine of 0, you idiot. 30. Oh, that's a nice one to work with, yes? Why? What is 0.5? Sine 30 equals 0.5, which is 1/2. So now can I put some numbers on here? What? I should have written that in purple, right? Because 30 was purple. Sorry. What should I put on the triangle right now? Where does 1 go? On the opposite, which is what? The vertical one or the horizontal one? Vertical one. 1. What goes on the hypotenuse? 2. Can we now find the third side? What is it? No. We have the hypotenuse. Should we be adding? Subtracting. So what is it? Root 3. Everybody cool? So, what does that mean for us? Every time we have a 30, 60, 90, those are your numbers. Right? What do you mean, Mr. Myers? Okay, what if this was 8? What would this be? 16. And what would this be? 8 root 3. Everybody cool? Easy peasy, yeah? Now this one's a little trickier, right? Because it's not always the same, yeah? We got to remember, what's across from 30? It's 1, yes? But if I change the measurements, it's not 1 anymore, but it is the shortest number, isn't it? Because 30 is the shortest angle. Shortest, wrong word. Smallest, thank you. 60 is the second biggest angle. Root 3 is not as big as 2, is it? So root 3 is like 1.73, right? So that is across from the middle, and the 90 is across from the big guy, always, right? Now, why am I making a bigger deal of this one than I did of the 45? Because this one will move around, right? If I keep this right here, and I tell you that that is 30, you automatically know 1 root 3, 2, right? But what if I make it this way? This is now 60. So what's here? There's the 1. What's here? Root 3. And what's here? Everybody cool? How we rotate this one messes us up a little bit. Everybody comfortable? So remember the ratios, right? This is whatever it is, Q to Q to Q root 2. What's this one? The 30 gets Q because it's right across from 1. The 60 gets Q root 3, and the 90 gets 2Q. Everybody cool? Now, this is going to mess you up a little bit because you guys don't like leaving them in fractions. You want to hit square root 3. But you've done enough radicals with me between grade 10 and now to know that we don't do that, right? So let's turn the page over and let's have a look. It's always the same thing. Terminal arm, reference angle, special. Identify the special triangle. This is what we just did. This is last page. And then we just do the notes. Or do the numbers. Okay, first one's easy. Sine of 45. Where is that? What quadrant? First quadrant right there, yes? 45, 45, 90. So I'm using the 45, 45, 90 triangle, yes? Which means 1, 1, root 2. And then all I do is the sine and the cosine and the tan for it. Tan is 1 over 1, sine is 1 over root 2, cos is 1 over root 2. Yeah? Okay, let's do the next one. We'll do that one in red. Where's 60? It's here, yes? Which makes that 60, so what does that make this one? 30. Now I know the triangle I'm using, right? What's across from 30? 1. What's the hypotenuse? 2. What's the longer side? Root 3. And then I just do sine, cos, tan, right? Now, what's happening differently in C? Where have I gone in the grid? I'm outside of the first quadrant, aren't I? So now not everything is positive, is it? I got some positives and some negatives, yeah? So I'm down here. What is the reference angle? 30. Now you will notice I didn't draw this like the 30, 60, 90 triangle, did I? Right? I just drew a triangle. Why? Why? Does it matter? Think about when we were doing trig in grade 10. Once you drew a triangle, it didn't matter what it looked like. You could do the trig, right? So if you want to get technical, you would want to draw this one the shallow and that one bigger. But do I care? No, I don't care what your drawing looks like. Your drawing's for you, isn't it? So now you know that's 30. So what's this? So what's this? So that's the 90 degrees. So what number's out here? No. -1. What's this? That's 2. What's this? It's not 2, is it? 3 people said it was 2. What is it? That's the root 3. What's this? 2. And then you do sine, cos, tan. And lastly, 225. That's going to be out there. What's the reference angle? Where is it? Right there. Sorry, it's not. It's going to be right here. What's the reference angle? Right there. What is it? 45. So I know I'm doing a 45, 45, 90. What is this? -1. What is this? -1. What is this? Root 2. Great. Now do sine, cos, and tan for all of them. Go. Everybody good? It's easy, right? Okay, let's do the next 4. Where's 240? Third quadrant, right? Going down there. What's the reference angle? 60. So that makes that 30. Put in your values. What's this one? -1. What's this one? -root 3. What's this one? 2. 210. Down there. There's 30. There's the 60. Fill in the numbers. 150 out there. I'm not going to give you any angles there, and I'm going to make you do 315 all by yourself. Note my classy progression from showing you almost everything to a little bit to almost nothing to nothing. It's like I've done this before. Satcho, you're not going to say 2 is in the wrong spot again, are you? What? Is everybody good with the special triangles? Check your work. Now, they're pretty easy to draw, right? Because when we draw the angle, there's only one option, yes? Because if I give you the angle, the terminal arm, there's only one place it can be, right? But when you look back on the first page, if we roll these things around, the numbers stay the same, but the terminal arm can be in more than one place, can't it? So let's look at what happens there. I have negative root 3. Cos of theta is negative root 3 over 2. So if cos is negative, how many places can it live? 2 different places, yes? Where can cos be negative? Mandarin. Second and... No. Second and third, yes? So cos, I have to be out here. Nice line. I have to be out here or out here, right? Now, I haven't drawn it to scale at all. I've just drawn where the line has to be, yes? Now I'm going to put in what I know. Root 3 over 2. What's cos? Opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent? Over hypotenuse. So, this is a hypotenuse, isn't it? Now, can the hypotenuse ever be negative? No. So there's my 2, there's my 2. Where's the adjacent? It's the horizontal. It's the x value. That is the x, right? So that has to be negative root 3. Agreed? Which means, what does that make these sides automatically? 1 and 1. Right? So if this is 1, it's the shortest side. So what must this angle be? 30. So what must this angle be? 30. Is either of those answers the answer I seek for theta? Are either of those theta? It's a yes or no question. No, of course not. Where does theta start from? Starts from the positive x-axis. So if I went all the way to there, what is it? 180. But I didn't go all the way to there. Where did I stop? Right here. So what is one option for theta? 150. Now, the next time, if I went all the way to there, it's 180. But I didn't go there. I went all the way to there. So what is it? 210. Everybody cool? All right, let's try the second one. Sine. Is that an x or a y value? That's a y value. Is that a hypotenuse or an x value? Hypotenuse. Is sine positive or negative? So where's the only places it can be? 1 or 2. The y value has to be 1. Has to be 1. The hypotenuse has to be root 2. Has to be root 2. What's the only thing left? Which triangle are we doing? 45, 45, 90. So 1, negative 1, and 1. Yes? So we know this is 45, and we know this is 45. So what are my two options? First one is that one. What is it? 45. If that, the second one, I go all the way to there is 180, but I bounce back there. So what is it? 135. Everybody cool? Okay, you do the last one. Tan's always the hardest one because it doesn't bump into each other, right? Tan's weird. You know, I'm going to just take a second to congratulate myself on how nice that coordinate grid is. Look at that bad boy. If I went and did this one, and I'll use a different color just to see how awesome I am. Look at that. That was freehand. You guys aren't as impressed as I am. See, that must be because you people still feel you have more to live for. When you get to be my age, drawing a perfect coordinate grid, that's a win. Maybe I could have been a neurosurgeon. But then, how could I have had all of these positive relationships? The only time I would have seen you was when you were asleep. If I was a neurosurgeon, I don't see you when you're sleeping and I'm a teacher. Actually, I see a lot of you sleeping when I'm a teacher. I won't point to anybody in particular, but I see a lot of kids asleep. Which sounds creepy, but it isn't because you all just sleep through class. Don't worry, I slept through class too. Look at how successful I am. All right, where's tan negative? Second and fourth. What's this? Really over. 1. Right? Right? Okay. So, and these are y's and x's, yes? So if the y is positive root 3, that's going to be there. Here, it's negative root 3. Where's the 1 go? Sorry. Yep. Negative root 3. Where's the 1 go? On the x. Negative 1, positive 1. So now we're done, right? What does this have to be? I drew it badly on purpose. What does this have to be? 60. Even though I drew it smaller than 60, it has to be 60 because 60 is what's across from root 3, right? So if this is 60, what's this? 60. So what's this? 120. And what's this? 300. Is everybody good? 45, 45, 90 and 30, 60, 90 are triangles that are used a lot. Okay? Look up. See that ceiling? I guarantee you that's a 30, 60, 90 triangle that they've cut off at that end. Guaranteed. Is everybody cool? Now, remember how I crossed out a few questions on the last 2 textbook pages, right? Go back to the first one, which had stuff I crossed out. Could you do number 8 on page 193 now? Yeah, you could, because we know now 30, 1, 2, root 3. You could have done 8 now, right? What is the sine of 30? 1/2. What is the cos of 30? What's the cos of 30? It's on page 193. The exact, I said on page 193. Oh. What's the cos of 30? Root 3 over 2. And what's the tan of 30? 1 over root 3. And you could fill in this chart now, yes? You don't have to because we just did it in our notes, right? Go to the next assignment I gave you. That was page 198. On 198, these are all special triangles, aren't they? Right? And if you look real close, you can see the textbook I photocopied out of. Somebody did the work in the textbook already. Punk ass. 60. So, except they did it wrong. That's hilarious. What a moron. Not me, not you, this idiot, because they filled it in wrong. If this is 60, there's the root 3. What's here? 1, and there's the 2. What's this one? What's this one? That's 45, 45, 90, right? So what's this? Negative 1. What's this? Negative 1. What's this? Root 2. 150. So what's this guy? 30. So what's this? 1. What's this? Negative root 3. What's this? 2. What's this guy? 90. So, oh, that's a weird one, hey? So what's this? Root 2. What's this? 1. What's this? 1. Because it's 45, 45, 90 again, isn't it? And then you could do these special triangle ones now, because you could do both those now. So everyone's cool, yeah? Everyone is good? All right. Do some proving of it. Page 201 has your first assignment, 201 to 202. And page 205 to 206 has your second assignment. You have 28 minutes right now, and then you have this evening. All right? I want to be marking these tomorrow morning. All right? Now, listen please. Listen please. Don't see I'm still talking. This is the end of SOHCAHTOA trig in grade 11. We will move on to trig on triangles with angles bigger than 90 degrees tomorrow. So we're going to have a quiz on SOHCAHTOA trig. All right? We will have that quiz. Oh, tomorrow's a short day. We should have it tomorrow. Because then we can mark the assignments and then do the quiz and mark the quiz, and that will take up the whole day. Yeah? Okay. Quiz tomorrow, SOHCAHTOA trig. So all reference angles, the 4 quadrants, what's in what quadrant, and special triangles. Oakley dokley? Oakley dokley. And we won't do that quiz until after we've marked these 2 assignments. Huh? Huh. X blocks? Oh, it's filling up. Tomorrow. They're only like 10 questions each. I'm giving you half an hour now. Every question requires you to draw 3 lines. All right. As always, I will take attendance and then be around to assist. I shouldn't say that. I should say, as always, I will take attendance and walk around and have you all tell me you're doing just fine and don't need any assistance.